Alrighty gang, this is an optional video. We're going to cover 3 topics. If these topics look of interest to you, feel free to keep watching. What is a method? What are if statements? Well, we know what an if statement is, but how we're going to write it in this language. And how to do while loops. So what is a method? A method is a function, but it's a little bit more than that. So when you did Python, or you did some C programming, or you did C++, you surely wrote functions, right? You would do something like this. DEF, and you could write a function that takes 2 variables and then return the result. You know, result equals x times y. And yeah, you could do this in one line. Return result, like that. That's a function. And of course, it would be slightly different syntax. In C, you would have to declare your types. It might be this: int multiply, int x, int y. We have to use our curly braces, and then we would do int result equals x times y, and then return result. I'm going to put some comments here that this is Python, right? And that this is C. Would also work in C++, since C++ is backwards compatible. Ought to work in C# even, but C# is like Java, in which case everything has to be part of a class. So what is a method? A method is a function that is part of a class. So in other words, it's a named block of code that is part of a class. And some textbooks call them weird things, like behaviors. I'm not going to call it behavior. When I lecture, sometimes I'll slip up and call it a function, since that's what it is in all the other languages when you're not doing classes, right? But a method is a function that's part of a class. So this would not be good enough. Instead, we would have a class defined. And our class might look like this: public class example. And if I was really going to get this to go, I would type it into Netbeans or another Java editor like TextPad. This is just a pure example. I probably should do it in Netbeans. Anyways, and so int mult parentheses int x comma int y in parentheses brace return x times y, or int result equals x times y return result. So int result equals x times y return result. And we would also have a main method. We would probably declare the methods to be public, because Professor Thompson's rules of class writing, they're not rules, so to speak. Sorry, pardon me.
That was one of your rules was private. Was it public?
Data is private. Methods are public. So I've already mentioned this then. So data, parentheses variables, ought to be private. And then methods, which are the functions, should be public. This is called encapsulation. Now, we don't have any data in this guy. If we were going to write a real class that did real work, we would make it separate from the main class, the one with the main method. But I'm not going to do that. Yeah, I am. Yeah, I am. I'm waffling on that. I'm going to go ahead and crank up Netbeans. Anyways, this is a method. It's part of a class. This is what's known as an instance method, because it does not have the static keyword there. Meaning that to use it, you have to instantiate an instance of the class. You have to make an example. You have to instantiate a method. You have to instantiate an object from the class. I'm going to change the name of it from example to math. Okay, so when you're getting ready to use that class, it's only got one method, but here's what we would have to do. Say we're down in main, something like that, and we have 2 numbers that we want to multiply. So down in main, down in a main method, in a client method, we would need to create something from this class. So math, I'm just going to call it M. M is equal to new math, parentheses, in parentheses, semicolon. That was the big trend in the 70s, learning the new math. Okay, now we're going to get a result from our method. So int result equals m.mult, parentheses, x comma y. No, not x comma y, 10 comma 20. We don't have any variables named x or y, so I'm just passing in some unnamed constants, some literals. And then we could print that out. System.out.println result. Right. That'd be enough. It's pretty lame. But this client method needs to be in a this client code needs to be in a main method for it to actually work. Unlike C++ or Python, absolutely everything has to be stored inside a class for it to get to work, for it to work.
You want to put the parentheses at the end of the result to get the print? You don't have to have that?
You mean a curly brace? Because I do have parentheses here.
Yeah.
Yeah, we need the curly braces. We need to put this in a method. So we're going to make another class, which is a driver for our math class. So in a separate file, we would put class. Now here's going to be our demo class. Curly brace, tab, public, static, void, main. Now Netbeans creates all this for us, right? And then down in main, this is our driver for the other class. Like that. So we would put this in demo.java. We would put this one in math.java, and I have a hunch that that would be a really bad name. I'm sure that there's a math class already, but anyways. So this is an instance method. It does not have the static keyword, so to use it you have to instantiate an object from the class. I'm going to move that comment up closer to where we actually used it right. Instance method means that if you don't have an instance of the class, you're not going to be able to use it. Now that's a lot of trouble to go to. Just to create, just to do some multiplication, it's annoying to have to create a new object to do some multiplication. This class doesn't have any data. If you have a class with no data, then it doesn't need instance members most likely. It probably needs what are known as class methods. We could turn this into a class method by adding the word static in front of it. I'm going to do for a different function, right? I'm going to make another function, another method called add, but this one's going to be static. So public static int add parentheses int x comma int y in parentheses, and then here int result equals x plus y. Return result. Now since it's static, this is a class method. Class method are defined with the static keyword. So sometimes you call them a static method. I'd rather use that term than class method. But are defined with the static keyword. You do not instantiate a new object. You do not create a new object. Instead, you call it by the class name. So, since this is static, we don't use that. Instead, we would do something like this. Int sum equals math.add, parentheses, 10 comma 20. And then we could print that out. You see the difference? We were able to use this without creating a math object. And you will see this all the time. There is, in fact, a math class which has sine, cosine, tangent, and power functions and stuff like that. That's why that's a really lousy name for it. So should not be have called it math. I should have called it something else, but I didn't type it into Netbeans. I'm not going to actually run it. Hope that makes sense. So I'm going to put a note here. This is a call to a class method. So no instance is needed. And this is a call to an instance method. So an object, parentheses, instance, is needed. The terms object and instance are synonymous. And instantiate just means to make a new object, like that. I guess I can move this comment up here. We should always put each class in its own file. You will see me not do that in my examples to supposedly save time. There can only be one public class. So I would have made that public right there, and I would make this not public. And that means that this is the primary class in that file, right? And we could have put this same class in here as long as it was not public, but that would mean that it's not accessible to anything except inside that file. So that's why you would normally put this stuff in its own file. Okay, so that's all a method is it's a function that's attached to a class, and usually it uses data that is part of the class. That makes sense?
Yeah.
We don't have any data in the class yet, but we're going to make an example, and I'm actually going to do this one in Netbeans of something with data. Now that one didn't have getters and setters and constructors and anything fancy like that. I'm just going to call this one demo. Lousy name for it, but that'll work. Now you probably saw that when I was creating a new project, that's weird. It's not liking the fact that I was trying to create a new project. All right, there we go. Oh, I always do that. I start to type the file name up here in the filter, and that's not where you put it. The file name goes up here, and it asks, do you want to create the main class on the spot? And yeah, we usually do, right? So we don't have to type in public static void main. So that's why I left that checked. That's why we see main here in a font far too small to read, so we're going to increase that. Okay, so we're going to make another class that's got some data in it. Maybe just a first name and a last name. Or we like doing math, it could be, a rectangle class. It's my traditional example, or a circle class, or stuff like that. Yeah, let's just do first name and last name. Nah, let's do the math. Let's do the math class. Let's do a good old triangle, and the area of a triangle is 1/2 base times height. So I'm going to create a new file, a new class, because this is going to be my driver, but it's going to take advantage of another class. Now, what a lot of people do is they start sticking their data straight in the class that's got created. They might start putting a math, height and width and radius and stuff like that all inside this class. But really, that's not data encapsulation. That's not object-oriented programming. We want to make a separate class that's got those things. So I'm going to go over to demo. And by the way, you can delete that word package. And if you do that, you're going to get a little warning up here at the top, or an error that says correct package. Remove that, move class to correct folder. That just takes it out of that subdirectory. And when I'm grading your assignments, I delete that word anyways. And so if you feel like doing that to save me 2 seconds, that's great. If you don't, that's also fine. Okay, so I'm going to come over here to source packages, add a new class, and I'm going to call it triangle. Basically, you always want to name your classes with uppercase letters and your variables and function names with your method names with lowercase. That's just tradition. All right, a triangle. Got several pieces of data. We're going to do double height and double base. And what do we like to do with triangles? We're always insanely curious about their area. I'm going to go ahead and leave my variables publicly accessible. If you do not, maybe if you took C++, you remember that everything is private until you change, to a public. In Java, everything is almost public. It defaults to something called package level, which means that anything in a package can get a hold of it, but if it's inside of another package, it can't get a hold of it. And public, the public keyword means that absolutely everything can get a hold of it. I'm going to leave these as default for now, and then if we feel like it, we will encapsulate them into getters and setters. So I am going to make my function, my method, get area, parentheses and parentheses, like that. And I already have forgotten something. What did I forget? The type. Okay, so public double get area. Now we're a lot happier. So we can return height times base. Or if we feel like it, we could say return this dot height times this dot base. That this keyword is not necessary in this instance, but it's nice to have because if you type this dot, then it's easier to choose, right, your variable names. Make sure you don't make any mistakes in typing it.
So that's the only difference is that it's easier to use this.
Exactly, right. That's the only reason under this circumstance. You wind up using the word this a lot when you're talking about it. In order to use that particular keyword, this keyword, there's only one time when you absolutely have to use it, and that's when you need to differentiate between another variable and the instance variable, the class member. So for example, if I wanted to create another variable called height, different type, same type, whatever, well, now it's complaining, right? You can't multiply a double by a string, or even if this was, an int or something like that now, whatever. Say that, we had used that 20 lines upper, but anyways, we have variable conflict. We have naming conflict. This one is not supposed to be referring to that one. It's supposed to be referring to that one. And that's when this keyword is absolutely essential. So you see me use it for setters.
So you can have one the same variable is the same, which you shouldn't, but you can.
Right.
You have this.
Exactly. Yeah, we can have easily more variables with the same name, and there is one time when it's appropriate, and that's for setters. I'll go ahead and make a setter for height just to illustrate that. Public void, because a setter doesn't have to return anything. Set height. I'm going to set base, easier to type. Parentheses in parentheses. We need to pass in some data to set. So double base. And now I can't do this. Base equals base. Well, I can. It's not a syntax error. But we had a naming conflict, right? We need to specify that this variable matches up with that one. And so we say this dot base equals base. If I had done something different, like if I'd said that variable was going to be called x, then I could just do base equals x, like that.
Okay.
If that's easier to type and you want to go with that, that's fine. I will do this, and then when you see Netbeans generate code on its own, it will follow that syntax as well. All right, now this is called a setter. More technically, it's known as a mutator. The book will use that term. Got to use a Latin term for it. Okay. But we're going to go back and we're going to make use of the triangle class. So I'm going to blip over to the triangle class. Excuse me, to demo. This is going to be the driver. Driver for the triangle class. Client is another term for that. Some textbooks call it the client, and suddenly I just spaced out on whether our textbook uses a term driver or client. I think it uses driver. Act of the client for the class. Now, a class can be a client for, of another class, and that class can be a client for another one, whatever, Here we go. We're going to use our triangle. Triangle T1 equals new triangle, parentheses in parentheses, semicolon. Now we need to set those variables. And we're not doing data encapsulation yet. If we're going to follow the official rules, we're supposed to encapsulate our data, and we would not be able to do this. But T1 dot set base equal to 10. T1 dot set height. Oh, I lied. There I'm trying to use the encapsulated versions. T1 dot base equals 10. T1 dot height equals 20. Did I put these get area method in there and have the right equation? I'm going to flip back to it to make sure I did. Yeah, that's what I figured. That's the wrong equation. For a triangle, it's half of that. So I'm just going to put 0.5 times this dot height times this times base. So flip back over to your triangle class and make sure that your formula is correct, because I didn't get it correct when I typed it in. And then I need to print the result. Well, I don't have to, right? System.out.println or printf, parentheses, quote. I like to demonstrate printf. Area is %.2f. That means print out the area to 2 decimal places. And then \n to go to the next line, because printf does not go to the next line, unlike println. So system.out.printf, quote, area is, that's a dot after that, %.2f \n, end quote, comma, and then the variable. Oh, I haven't even calculated the area yet. I'm going to go ahead and type in area there, but we're going to have to create that variable. It's an uncreated variable yet already. All right, so above that, we need to declare that variable. Double area equals T1.getArea, parentheses in parentheses. Alrighty, there's a legitimate complaint about object-oriented programming, but it's a complaint for examples that are this small, right? This is a pretty trivial example of object-oriented programming, and that's why it seems like it's a lot of work to do what we just did, which is to calculate the area, right? We wrote an entire class, we added methods, we could get the same functionality. I'm going to write the example in Python, not Java, but I'm going to come over here, all right, and we could have done all that like this, right? We could have said base equals 10, or even, double base is equal to 10, and then double height is equal to 20, double area equals base times height times 0.5, and then system.out, well, however we're going to print it, with printf, println, whatever. Right. That's all we needed to solve that problem, technically. And I need to tab everything correctly, and I'm not in a coding editor, so forgive me for taking a moment to do that. All right. Right. That would calculate the area of a triangle. But if I ask you to write a class that contains data members and methods, you wouldn't get any credit for this. But it solves a problem. So people who are already experienced programmers or have taken other languages but they haven't done object-oriented programming, they complain about, or not necessarily complain, but I had the question raised. Why are you going to so much work to do that? And the reason we're going to so much work to do it is we are in training for creating more complex solutions. The more complex solution might be that we need more than one triangle. We might need 100 triangles. We might need to stick them all in an array and process them all at once. We couldn't do that easily, right? I don't want to create 100 different, pairs of variables, and stuff like that. Or we may have a lot more data to encapsulate. We might have a lot more data than just 2 pieces of data like that. and it could be hundreds of pieces of data. And it could be an employee record with a first name and a last name, and a hire date, and an employment history and medical records, and might have all of that information in it. In which case, putting it in a class lets us treat it as though it's one piece of data, right? I have one triangle, I have one employee, and I could write that employee out to a file. I could save that triangle out to a file. I could communicate, that employee over the internet or save it to a database or whatever. Whereas if it was a whole bunch of discrete pieces of data, it's much more difficult to manage in the long term. And if you're writing something that uses like a graphical user interface, something with buttons and drop-down windows and stuff like that, you pretty much have to do object-oriented programming. Back in the 80s, when people had Windows 3.1 and Windows 3, they didn't have object-oriented classes in order to control the operating system and to control the creation of windows and stuff like that. And it was incredibly hairy to do that. And now that there are nice libraries full of classes, it's real easy to create, applications with windows and, and pull down menus and whatever. And so you create a menu class, and then whenever you want to create a window, a new menu, you just do that. You create a menu, and then you specify what menu items you want in it. And so you can have 27 different menus in your code, and it's easy to keep track of. I don't know if I sold you on that yet. Hopefully you'll just roll with me and say that we're doing learning, right? Just like you have to learn how to, dribble the ball with your feet if you're learning soccer or whatever, right? You may think that, well, I know how to kick a ball, but, it turns out that in order to play good soccer, that there's more to it than that. Okay, so we have done everything except for the data encapsulation. Yes, sir.
Can you go back to the triangle?
Uh-huh. Whoops, wrong one.
On the public double get area, you have return 0.5. You don't have to have the. I've never seen it wrote like that before. Wrote return 0.5.
I could have done this, and this is. I like doing it this way actually. Double result or double area or something like that equals, and then that formula, and then I could return area. I actually prefer that. I think that's a better solution.
Yeah, okay. That's the way I've seen it. I've never seen you do it. I've never seen it wrote out the way.
Yeah, you can do that all in one fell swoop.
Okay.
So the act of making these things private and then making public methods that manipulate them is known as encapsulation or black boxing. And the idea is that in my client code, I don't need to know how this data is stored, right? If I'm going to create a triangle and use it here, I have to know that these are numeric values, but maybe they're not stored as numeric values. Maybe they're two separate elements of an array or something like that. Maybe for some reason I feel like changing it so that behind the scenes that data is stored in an array. That would break this code. If we encapsulate it, we are separating the implementation from the presentation. And so the same code could work no matter what the data format was. So that way we can publish a class, and then if we ever have to make changes to it, it's possible that it wouldn't even break the client code. We can make all sorts of changes to it. We might need to add additional variables to it or change their types or whatever, and it still would not necessarily break this code that uses it. So in order to encapsulate our code, we need to make, wherever it was, data private, methods public. I don't remember where I typed that now, but I said that. So what we would do is we would type, whoops, I'm in the wrong class. I would go to triangle, and I would type in private double, not provate, private double, and then private double there. Now and then when I save it, I'm going to see that creates an error over in our driver class. If I come over here, it's because this code is trying to access those pieces of data directly, but it cannot because they're private. You can only access variables directly like that from the client code if they are declared as public or left at default status, default access. So to get that to work, I would have to use the setters. We've only made one setter, but I may as well use it here. I'm going to comment that out and instead use the setter, t1.setBase, parentheses, 10, in parentheses, and I need the same thing for the height variable, but I don't have one yet. And I'm often fond of cheating and letting Netbeans create my getters and setters. But I'm going to go ahead and add a getter for the base since I've already added the setter, and then I'll let Netbeans do the height because I like demonstrating both ways. We don't even technically need a getter because we never use the get here. But we could, right? We could print out that the triangle has, you know, a height of and a base of, in which case we would need getters, right? So system.out.print line, parentheses, height equals space plus t1.height in parentheses and semicolon. Now that's another error because we're trying to access a variable that's marked as private. So that's not going to work. We're going to have to change that to a getter. Let me push this over so we have more room. I'm going to comment that out, copy it because that's easy to type. When you see me copy things that quickly, what I'm doing is I'm holding the shift key and the down arrow, the down cursor. That lets me grab a lot of things at the same time, and then the command key, Control C, to copy. Just letting you know that that's when you see me making really fast changes. I won't always go and grab the mouse and highlight and, you know, paste that way. All right, so anyways, there, I just pasted that. No, that's wrong. Let me copy that line. That's what I meant to do. All right, but I'm not going to call t1.height. I'm going to call t1.getHeight, which is not created yet, so that's an error. Let's go and fix those things. We're going to add getters and setters for all of our variables. We've only got 2, but that's enough to demonstrate it. I'm going to go back over to triangle. We have set base. Why not make a get base? Public. Now I can't make this void because it actually returns a value. Yep, so it's going to be double because that's the type of the data. And then get base, but we don't pass in any data. So parentheses in parentheses, curly brace, return this dot base. And you don't have to use the this keyword because there's no variable naming conflict. But I like typing it, right? You type this dot and it pops up a list of variables. You feel good. And I'm going to put that this is a getter, parentheses, accessor. All right, so pause the recording if you need to type in all of that. We should at this point have working code. No, that's not true because I don't have a setter for the other piece of data, right? If I blip over to demo dot, right, that's still accessing a private variable. And as mentioned, I can let Netbeans create the getters and the setters. Now I want you to know how to do it, right? You may be using some, text editor rather than, Netbeans. But what I do is I highlight those variables. I come up to refactor and choose encapsulate fields. Field is Netbeans' term for instance, remember, instance variable. Refactor. Yep, you highlight the variables that you want to refactor. And unfortunately, it puts all of its new methods above the data. I like having the data at the very top of the class. So I'm going to cut those guys and put them up at the top of the class. But we see what it did. It created a getter called getHeight, and it created a setter called setHeight. So it did that for us when we chose refactor encapsulate fields. Just saves time. But I am going to cut those guys. I'm going to paste them up here. And then we see that it loves to put all these Java comments. And that's great and all that. But for cleanliness of code, I'm going to remove the extra comments that it gave me. All right, now while I'm looking at this, there's one more comment I want to make. If I tell you to create a class that calculates the area or the perimeter or the surface or the volume or whatever, here's what people always do. They come up here and go, well, I'm going to need an area, right? And I'm going to need a, but don't type this. You don't want to do that.
That's what I did last program.
Yeah. The reason you don't, I mean, it's not technically wrong, but it's poor form. And the reason it's poor form is because once a variable changes, right, they call set height and they set it to a different height, then whatever area was calculated here is now incorrect, right? It's stale. It's old data. It no longer matches the values of base and height. And so if you have another method in here that uses this variable for whatever purpose, then if somebody calls set height and they changes the value of it, then area is no longer good. So if you're calculating values, then don't create variables up here to hold those values. Put the variables inside the method. Make them local to the method because you want them to be calculated every single time. You don't want to cache your data up here and then your data can become obsolete if those values change. Now I'm not going to fail you, if you create an area variable up here rather than down here, but it is poor programming and I would point it out. Okay, does that make more sense now? How you structure the methods, you always put them in a class. There's no way to not. Functions have to be part of classes in this language.
Yeah, it makes sense.
Okay, cool.
How would I run in the demo?
Oh, I haven't fixed it yet. Let's go back to demo. And instead of t1.height, it needs to be t1.setHeight. So t1.setHeight, parentheses 20. All right, now it's possible that after I make all these changes, even though I've saved them, it may just still display that there's an error of some kind here. What you always want to do is do a rebuild. So you're going to come up here and click the hammer and broom, or you can find it under Run, Build Project. And when you do that, it says it's building over here. Oh, and on our screen, we can't see it on the projector, but it did say that it was done. I'm going to fix that. If I don't see my output, I can choose Window, Output, and there it says Success. Right. If you have errors, they will show up as red lines over here on the other side. And guys at home, I'm sorry, guys and girls, I should not use, primarily male language. You will see them marked by red notes over here. Right, so if I get something wrong there, you'll see it flagged as red over here, and you'll also see it flagged as red over there. So you just click on that, and it'll take you to it. Sometimes you'll see warnings, and the warnings are yet marked in yellow rather than red, and you can usually ignore them. I'll say that. Once you get in the habit of clicking on something over here to fix it, right? Like I did with package, when it said package, don't type this because that's an error until I fix it, right? It's going, hey, that's a problem. I can click this and I can say move class to correct folder, right? It offers me all these choices. Only choose the choices here if you understand what it's doing. And I'll show you what people do wrong. They will type in something like this. Oh, I need some strings. So string name equals Bob, right? And I go, well, I got an error there. Okay. Create class string. Boom. Now I've broken the code. Now I cannot, now the code is still broken. Well, what's wrong with that? I know that's how you use a string. Well, the problem is that in this language, string is a class, and so we have to use an uppercase S rather than a lowercase s, and we created an empty class that does that. Similarly, if I forgot that triangle was created with an uppercase T, and then later on in some other piece of code, and again, don't type this is erroneous, triangle T2 is equal to new triangle, And then I want to do I'm typing along, and I think I'm doing awesome. T2.setBase100. Now I've made several typos. I didn't make an uppercase T. I didn't put an L there. I come over here and go, oh, yeah, I'll create a class. Yay, the error went away. But the error didn't really go away. Set base. Well, dadgummit, I've got to click that again and change type of T2 to... now it's actually... Netbeans is trying to save our butt here. We come over here, cannot find symbol. All right, create a method set base. I might be able to get all the errors to not show up, but what is happening is I created a class that is wrong. Right now I have a triangle class and a triangle class, and this just has something that would throw an error, that would crash if it was called. So never choose create class, even if it offers it as a choice, unless you're profoundly sure that that's what you're supposed to be doing, unless you're profoundly sure you understand what it's doing. A lot of other errors you can correct, right? If I use a class that it understands about, right? Like the scanner, we always use the scanner all the time, right? Scanner SC equals new scanner, parentheses, system.in, right? And it'll come up and it'll say, I mean, you already know from your Intro to Java class that you have to go and add an import up there. Netbeans is trying to be nice enough to let me do that, add an import for java.util.scanner. Save me the time of having to go up here and do it by hand. Doing that add import's fine, right? Doing the fixed package thing is fine. But don't just immediately run over here, click on an error, choose the top one, and expect the problem to go away. Most likely you're introducing more problems than you're fixing by doing that. Alrighty, how about if statements and whiles? Let's do a while loop first. I want to calculate the area of a triangle that's 1 by 1, and then 2 by 2, and then 3 by 3. So I'm going to need a variable. Now, a for loop would actually be better for this purpose, but let's just do a while loop this time. Int x equals 1. I just need some counter, and I'm giving it a lame name. While, parentheses, x is less than 10, in parentheses, open brace. Let's create a new triangle. Triangle, no, I'm misspelling it. Triangle T equals new triangle, parentheses in parentheses, T dot set base, parentheses x, and then T dot set height, parentheses x. Now what I'm going to do is I'm going to print some output for that. Let's get the area first. Double area equals T dot get area, parentheses in parentheses. Why am I getting an error there? Oh, I already have a variable called area. I'm going to remove the declaration for it. Or I could create another variable. The C++ language would not complain if I did that. But if you expected it to be the same variable, if you expected to be able to get out of the while loop and it still accesses data, that would not work. It's generally a good idea to only have one variable of the same name in the same block of code. All right, and then let's print that out. System.out.printf quote %.2f x for by %.2f triangle. Let me close these windows so I can type a lot more text. Area equals %.2f \n. And then after the end quote and the comma, let's fill in those placeholders. We have three placeholders to fill in. So T1 dot get base, parentheses in parentheses, comma. T1 dot get height, parentheses in parentheses, comma. And then T1 dot, oh, I've already calculated the area. So I could just use area there. Or I could call get area again. Now this is going to be an infinite loop unless I increase x, right? Because if you don't modify your loop variable, then you get into a problem. So just x plus plus at the end. Now I'm going to add some more comments to make things easier to follow. Excuse me for scrolling this up. This is the end of while. Don't have to add it, it's just a comment. This is the end of main. And that's the end of class, because I guarantee that after you edit these things, you're going to wind up in the situations where you have too many curly braces or you don't have enough. And if you start sorting them out like that, it helps. Yeah. All right, now I'm going to run it. First, I'm going to build it. Technically, it'll rebuild it when you run it, but I like seeing it run. I like doing that separately. So I'm going to run it. It says build successful. Excuse me, I'm going to build it. Now I'm going to run it. And as long as I don't have my printf marked wrong, created wrong, it tells me. Now look at that. Now I've goofed. Well, why did I get that? Why did it say 10 by 20 every single time? If I come up here, I'll see why. It's because of my dumb variable names.
What they set to 10 and 20?
They're set to 10 and 20 way up there, but what's that variable name compared to my brand new triangle?
T1.
Right.
Yeah, it should be T.
It should be T.
Okay.
So let's get rid of those. And there we go. A 1 by 1 triangle is in fact 0.5. A 9 by 9 triangle is in fact 40.5. Okay. Now say for some reason we hate triangles that have an area of 5. Or wait, let's pick one of these at random. We don't want this particular one, 12.5. 8. We're prejudiced against ones with an area of 8. So we're just going to come up here and we're going to add an if statement. After we get the area, we're going to do if, parentheses, area not, or area equals 8, or 8.00, either one works, in parentheses, system.out.println, skipping that one, exclamation mark, semicolon, or excuse me, end quote, in parentheses, semicolon. Else, open quote, tab that over, and then close, not open quote, open brace, have our printf statement there, and then close that brace. Now this is just a silly example. Just wanted to put in lots of good stuff in it. All right, so when I run it, I'll look at my output. Yeah, it skipped that particular one. All righty, does that make sense?
It does. In the if statement, when would you use this?
There's absolutely no reason to use this here.
Like inside, like instead of doing if area equals 8, would you ever use this, that area?
There's no this reference here because we have no data inside this class, right?
Okay, I see what you're saying. Yeah.
And we could, but say, for example, I like that string, but I decide that it needs to be accessible for more than one method inside the demo class. That's the only time you make a variable that's part of the class rather than a local one, is if it's going to be shared by more than one function. What if I have two functions that need that name? I could declare name up here. Now it's not complaining about that, but I'm going to get an error when I do this because this one is declared as static and this one is not. If you have a static method, it can only access static variables in the same class. So I would have to declare this one as static as well. Similarly, if we're going to write new functions, new methods, and add it to the class, if we want to call them from main, we're also going to have to call them static. Like if we do this, you know, public void set name, and inside it, parentheses, excuse me, yeah, public void set name, open parentheses, close parentheses, open curly brace, and we set name equal to Bob, like that, or Joe, I don't care, end quote, end semicolon, like that. And then I decide to call set name down here, set name, parentheses, in parentheses, that's also an error. I'm going to, because this is a static method, and if we want to call other members of the same class, they also have to be static. Like that. And if you're familiar with C#, you know, don't got to do it that way, because the main method does not default to being static. But in Java, they do. I'm hoping you won't put too much data inside your main class, the one with the main method. I would rather you put all of that stuff in other classes, right, like a triangle class or whatever. And then if you had a name, you could create, you know, a person class that had a name member and stuff like that. But if you do have a variable up here, you can use this reference, except you can't here. Because if I do this dot name, we don't have a this object, right? All of this stuff is static, meaning that nobody ever instantiated a demo class, right? We don't have a demo class floating around, and so we don't have an instance to manipulate. If you have a normal class with normal stuff, like that, then sure. Like so. Apparently, I mean, let's say that for no good reason, we hate setting the height to 3. So I'm going to go to the setHeight method down here, and I'm going to do if this, wait, I'm going to do it after that statement. If, parentheses, this dot height equals 3, in parentheses, curly brace, system dot output, or system dot out dot print line. But I hate 3, exclamation point, end quote, end parentheses, semicolon. Right. It was fine to do that here.
In there, okay. I think that's where I always get mixed up, is here and then the other program.
Yeah. You never use this dot if you're accessing local variables. Right, if I create some variables here, like int x and int y and stuff like that, I would not then subsequently go if this dot x and int this dot y. You only use the this keyword to reference variables that are declared as part of the class. Non-static variables that are declared as part of the class. All right, I'm going to undo all those changes after you look at them and admire them for a moment more. I guess we could run it. Let's see if it works. Oh, I still have an error in the demo class from all that name business. I'm just going to delete it all at this point. Not really pertinent. Got to build it with the hammer and broom. Run it. All right, at a certain point it says, but I hate 3. Okay.
Okay, that makes sense. I see where I was getting confused. Because I remember doing a program last semester, and I never did figure out how to get it to work. It's all because of the if statement and this. And
Right.
I never realized, okay, I get it.
Yeah. And you can avoid using the this keyword everywhere unless you have variable naming conflicts. So for the setters, theoretically, you could make the setters the only ones that use the this keyword. And if you wanted to get rid of the need for that, then you would just use a different variable name there than there. Like we could say double x and then set this dot base equal to x, and we would not need that. So if you want to, you can do away completely with using the this keyword, but it's worth knowing because it's awfully nice to actually have good variable names rather than x. For something as easy as a setter, sure. you could do that and it wouldn't make, right, wouldn't make much difference. All righty.
Yeah, I got it.
We appropriately pumped up? Okay. All right, I think we're done. So, you don't have to upload anything for this. I guess I could create a Dropbox. But, nah. But I am going to post this as a lecture, optional lecture for people to watch. And I hope it was good. By the way, we are recording these at 2 o'clock on Mondays if you're taking the spring 2019 semester. Right. We are reusing some lectures from prior rather than re-recording them because the in-class version of Advanced Java is only meeting once a week. And so they're actually using some of your lectures and this and that and the other. So anyways, we are reusing some lectures in the past, and that's why it made mention of, you know, coming to class and meeting, things like that when we're not doing that. But now we are. So if you want to come in at 2 o'clock, room 203 in the business department on Mondays, then feel free. Please do. The more the merrier.